We want to break down the number 48. Excuse me. Now by breakdown I just mean we want to write 48 as a product of two other numbers. Doesn't matter which two. Let's just say 48 equals 3 times 16. Okay? Now, can we break down 3 into smaller numbers? No. We can't break 3 down into smaller whole numbers, but we could break the 16 down so that we'd get 3 times, let's say, 4 times 4. Now, can we break a 4 down? Yeah, we can break 4 down into 2 times 2, and since we've broken this 4 down, we might as well also break this one down. And now, none of these numbers can be broken down any further. Now we note that we get 4 2s and 1 3. As a matter of fact, we could write this number as 2 to the 4th power times 3. Let's try to break 48 down in a different manner. Let's see. Let's say instead of doing it as 3 times 16, let's do it as let's say 6 times 8. How about that? Well, let's see. 6 can be broken down. Seems like there's only one way to do that. 2 times 3. What about 8? Well, 8 can be broken down into 4 times 2. And now if we take the 2 times 3 and the 4, breaks down into 2 times 2, and then there's another 2. Well, it looks like we get the same thing we got here again. It looks like we've got 2 to the 4th power times 3. Let's find another way to break this down so that it can't be broken down any further. Let's see, 48 equals, I'm just going to start with the smallest number, 2. 2 goes into 48. Well, I wrote that wrong. That should be 2 times 24, right? I was saying 48 as I wrote down the 24, and as a result I wrote down 48. So let's fix that. Okay, 48 is 2 times 24, isn't it? Now, go ahead and finish breaking that down. Pause a minute and see what you get. Now, I'll do it for you. 24 could be written as 2 times 12. Now, what I'm going to do is I'm going to continue dividing by 2's as long as I can. 12 is 2 times 6. And 6 is 2 times 3. Okay, so there's what I get. And again, I get 2 to the 4th times 3. Now, is this always going to happen? If I always break the number 48 down as many and as in the smallest parts that I can, which is essentially what I've done here, well, I always end up with the same thing. Well, we lose focus. Let's see if we can get that back. There we go. Okay. The fundamental theorem of arithmetic, well, let me back up a second. 48 equals 2 to the 4th times 3. That's called the prime factorization of 48. Now, what do I mean by prime? Well, a prime number is a number that can't be broken down. And your book will give you a definition of prime numbers as numbers that have only 2 divisors themselves in 1. And we'll talk about that in a minute, but that's what we call this. And the fundamental theorem of arithmetic tells you what we just experienced with 48. Now, we haven't broken 48 down in every possible way, but if we did, we would find that it always comes out the same. So it basically says the prime factorization, the prime breakdown, is always the same. Or the prime factorization. Now you can read the formal statement in your book, but this is really what it means. When you break a number down, you always get the same thing. Now, when I say we always get the same thing, you say, well, I got the 3 first here, and the 3 appeared second here, and then the 3 appeared last here. That's not different. They all can be written as 2 to the 4th times 3. They're all the same. Every one of them is identical to the other, in that each one has 4 2s and a 3. And as we know, order and arrangement of products, of the numbers in a product, makes no difference to the product. The constituents are always the same. No matter what order they appear in, there will be 4 2s and 1 3.